So now let's get Lee, who just got a grant funded by PCORI and is related to data registries.
Hi, many thanks to the organizers for the opportunity to present here. So what I'll do is to present our new project, Building Data Registries with Privacy and Confidentiality for PCOR. It's newly funded by the PCORI, the Patient-Centered Outcomes Research Institute. So thank you, PCORI. And also, this is in collaboration with UC San Diego. The co-investigators at the UCSD is Dr. Xiong Jiang and Dr. Lucila Ochoa-Monado. So I have acknowledgement at the end of the slides, but in case I run out of time, since we only have 9 minutes, I'm going to just say it now. So this project, I think, directly grown out of the collaboration efforts with the IDASH Center here. In particular, I actually did my partial sabbatical visit last fall here at IDASH. And one of my PhD students, Hao Ran, she has done 2 internships here at IDASH for the past 2 summers. So many of the preliminary work she did contributed directly to this project. So I want to mention that. Also, it's interesting that the projected contract date actually starts today. It's September 15th, supposedly, for this project. So I thought we didn't get the money yet, but I thought it's appropriate or proper that I'm starting to work on the project to give the presentation. So quickly, as a motivation, it's motivated enough in previous talks. We have a lot of electronic health records which enable the patient-centered outcomes research. However, in order to build the data registries for to support the patient-centered outcomes research, we really need to protect the privacy and confidentiality of our patients. In most current practices, so we can build a registry using raw data. Subject to policy setup and IRB reviews, of course. So in addition to the overhead of the IRB reviews and policy setup, the patients have fears and anxieties over the loss of privacy and confidentiality, which affects their willingness to share the data, to consent. So an alternative approach that many institutions have been using is to build data registries using de-identified data, where the data are de-identified by removing the identifier information or generalizing the identifier information and so on. However, time and time again, it has been shown that this kind of approach is not sufficient against re-identification or disclosure risks. Xiao Qian has actually given some examples in his talk. In addition, there's a lack of transparency and accountability in the use of de-identified data. Very few institutions actually have in place, when they use de-identified data, they don't have a system to keep track of what kind of data are being used for what studies. So iConquer, Lucila just presented, is actually a good example that we're doing. We're moving towards that direction to make data accountable. And finally, there's lack of proof that the de-identified data with important information removed are indeed useful for PCOR studies. So these challenges have significantly hindered the PCOR research or just in general data sharing for biomedical research. So these are the challenges, exactly what we're trying to address in our project, building data registries with privacy and confidentiality for PCOR. Here is an overview picture for the project. For now, you can just ignore the details, just think of it as a black box. What it does is, given the patient records, we want to build data registries that consist of statistical and synthetic data that have rigorous privacy protection, and these registries can be used for PCOR studies. To follow Lucila's acronym trend, so we named the tool, ultimately we want to build a toolkit that's named PShare, stands for Patient-Centered Statistical Health Information Release. And fundamentally different from the de-identification approach, here we're using the state-of-the-art differential privacy or the framework. So it's really very much aligned with the patient consent principle. So we all know patient consent is a fundamental patient privacy right they want to have. Here, differential privacy, basically what it guarantees is that given a data set or population of patients, given any particular patient or record, if he or she opts in or opts out, the outcome or the aggregated data that we get should be indistinguishable. So that really gives us a rigorous way of sharing data to use the aggregated data for analytics for medical research while guaranteeing the patient privacy that participates in the data set. Of course, everything comes at a price. Given this rigorous privacy guarantee, the data we're able to share is going to be statistics or pre-computed statistics, which many times actually calibrated or perturbed, and the synthetic data that are actually mimic the original data, but it's not the real raw data. So given this, what we envision is that it's not going to replace the raw data. However, it will provide a complementary methodology to data sharing, to current data sharing practices, so that it's fast and it's privacy preserving. So researchers can actually take this synthetic data set and do some exploratory analysis, do cohort identification, and so on, before they determine the need to actually go after IRB and to get access to the raw data or a subset of the raw data. So that's our envision use of the system. So to give you a quick idea, so we do have a quick demo that's built up to given original data records, how we can actually generate synthetic records that guarantees differential privacy that you can actually use for research purposes. So there's always a risk of running live demos. So I'm just going to quickly walk you through a couple of screens. But the demo, in fact, actually works. It's a web app, so you're more than welcome to visit the web page and play with it. So here, the first screen, you can see you can upload some data, which can be in various format. Once you uploaded the data, and given each data file, you can run different algorithms to generate the synthetic data that mimics the original data. Once the synthetic data is generated, you can download the result file, which is basically a set of the synthetic data. You can also visualize how the synthetic data is different or is similar to the original data. So here you can see these shows a few marginal histograms of the original data versus the synthetic data. The green is the original data, and the red, if you can see, is the synthetic data. So you can see they're fairly similar to each other. So of course, this tool is very preliminary. Our project goal is, of course, to make this usable both from the usability point of view and from the algorithmic point of view to make the data truly useful for P-core studies. So what I'll do is to highlight just a few features or the approaches we're taking and a few challenges that we're addressing in the project. First of all, our approach is data and research driven, meaning in order to support common P-core studies or biomedical studies such as cross-sectional studies, longitudinal studies, we really need to make our methods work for multidimensional data and self-correlated sequential data, and also provide data utility guarantee. Since data are perturbed, so we want to make sure both analytically and empirically that the data are useful for these studies. So we're going to demonstrate these using use case studies from Emory as well as UCSD. And in addition, most of current data privacy research have been treating patients all as the same, meaning they have the data are equally sensitive or they have the equal privacy preferences. But in reality, patients have different privacy preferences. Some of them may be willing to share the data in open consent. Some of them may be more restrictive in terms of sharing the data. So how do we communicate these patient risks to the patients so that we can empower them to make more informed privacy choices and privacy control? And then given these fine-grained privacy control, how can we build systems that actually take into account these privacy choices and preferences? So that leads to the three aims of our project, where we're going to build data registry using private data alone, and data registry using both private and consented public data, and also building data registries with more fine-grained privacy preferences. So in the interest of time, I think I only have 2 minutes. I'm going to skip some of these technical details, but this is just the first aim that we're trying to build data registries that for multidimensional as well as longitudinal or self-correlated data. The current existing approaches, mostly they deal with the data using either parametric or non-parametric methods, where they either assume a multivariate distribution or just learn the empirical distributions from histograms. And all of these have some limitations. So our approach is to do a semi-parametric method, which we really just combine the best of both worlds, that we learn the marginal histograms first and then use the copula functions to model the joint distributions or joint dependence between these attributes or dimensions. So our preliminary work has suggested that it achieved reasonable or actually very promising accuracy. Of course, there are a lot more work to be done. So our plan is to further develop these methods and doing evaluation using the cohort discovery use cases at Emory and UCSD. For longitudinal data, we have sequential data which involves repeated observations of certain variables of a patient, for example, or just repeated encounters. So our approach is to use a prefix tree to actually represent the long sequences or represent the patterns. And again, we're going to do evaluation at UCSD and Emory for the readmission study. So this is the registries with private consented data. And of course, we want to also make sure that the patient privacy preferences are actually taken into account. So given, again, we're running out of time. So as I predicted, so I'm going to skip this and then move on to the acknowledgement slides. Just very quickly, these are the students and people who have worked for this project. And I look forward to carrying out this project with the investigators here.
Yeah,
Thank you.
Lee. As you know, I'm following.
Right on time, right?
Yeah. So I must say we had an original plan, but then everyone was agreeable to sharing their time so that we could include this new and exciting project. So I would just ask all the speakers to stay within the 9 minutes so that we can have a few questions, perhaps.